Hello, in this video we'll be looking at a question from the A-level paper 1, more specifically paper 1-2 from the year 2023. This is the question we'll be looking at today, and I'll be doing the solution out on the whiteboard, hopefully just like your teacher would if you were in school. If you were looking for another question from this paper, you should be able to find that in a playlist below the video. Okay, let's get to this question. In question 11, it's pretty much a general problem-solving question revolving around differentiation. So for 11 part A, they even start us off by just asking us to differentiate this function here. So A wants us to just get dy dx of this function. So the function is y is equal k multiplied by square root of 4x plus 1 minus x plus 3. I'm going to go ahead and rewrite that because I find a lot of students, this helps a lot of students. Instead of square root, we'll put in 4x plus 1 to the power of a half minus x plus 5. Okay, first thing I'm going to do, I'm going to differentiate this in one go in my head pretty much, which is a little too fast for some students. So after I do this, after I answer the question, I'm going to just answer it again a little slower, so bear with me if this is too fast for you. So I'm not going to use this one, I'll use this one up here. dy dx, we have three terms. There's one term, two terms, and three terms. The first term, we're going to have to use the chain rule. Okay, so to differentiate this, k is left alone, and the power of this term here is a half. We multiply down by that, and we take one away. And we leave the term alone, 4x plus 1 minus a half, we take a power away, and then we multiply by the derivative of this term. Now I think a lot of students are actually, let me finish the question, sorry. Differentiate the next term. The derivative of minus x is minus 1, the derivative of 5 is 0. Okay, now we're finished. Now I think a lot of students are happy with this, and let me clean that up actually. A half multiplied by 4 is 2x, and the power of minus a half, we could put this in the bottom row, it doesn't really matter. 4x plus 1 to the power of a half, and that's minus 1. Okay, we're finished part A. A lot of students are happy to do that. Chain rule, it's a very systematic, repeatable way to do it. But let me just do that again. Let me just differentiate this one term again a little slower. Let's write y is equal k 4x plus 1 a half. Forget these two, I don't care too much. Again, we're finished already. This is the question answered. If you were happy with that, skip on to part B. I'm just going to slow it down because some students aren't so good at the chain rule. So another way to have answered this would be to make a substitution. U is equal 4x plus 1. So instead of doing dy dx, and let me write y again here, y is equal ku to the half, ku to the half. Instead of answering dy dx, or to answer dy dx, we'll have to answer dy dx, we'll have to use the chain rule. What the chain rule is this equals anything that matches here. So in this case, du. So if we're replacing a u, we just put them in here. And each of these terms are much easier to do now. dy du. Here's y, here's u. It's very simple derivative. The derivative of this is minus a half. Sorry, this should be a half. My apologies. That should have been a half all along. So the derivative of this is a half multiplied by k, and add one on, take one away from this term, u to the minus a half. du dx is quite easy to do. The derivative of du dx, the derivative of this is 4 and 0, so multiply that by 4. And u is just something we replaced, so let's replace it back. That's a half k 4x plus 1 to the minus a half and multiply by 4. And that's what we did really quickly in our head. So I just wanted to do that a little slower for some students. It felt a little too fast doing it in my head. Okay, that's how we answer that question. Here's the answer here. Okay, let me clean this off. I'll write this somewhere up here and we'll do part B. Okay, I wrote the answer to part 1 up here because we're going to use this for part B. And part B, they ask us to find the x-coordinate of the stationary point in terms of k. So one thing, hopefully you've noticed is I've not drawn any pictures of this. We have an equation here. I've not drawn any pictures, and that's on purpose. The examiner gave you an awkward function. Most students don't know what the square root function looks like, let alone square root minus another x. Because they want you to see, can you do a maths question without any pictures, just using the maths and the words, basically. So I will draw a picture, I think, for part C, because I think it'll help us get an idea. But let me draw a picture now as well, but I'm not going to draw a good picture. I'm just going to draw a generic function. This function does not look like this. But I just want to point out, stationary points are these bumps here, and the one thing we know about stationary points is dy dx equals 0. That's what, when you see a stationary point, you should be thinking of some image like this, and you should be thinking dy dx equals 0. So I guess I don't need to have drawn that, but anyway, that's what I wanted to say. And we have dy dx here, so let's write that. 0 is equal to 2k over 4x plus 1 to the power of a half minus 1. And let's rearrange it. Sorry, they wanted the x coordinate in terms of k. So telling us it's a stationary point gave us this equation. We know dy dx equals 0, so now we know 0 equals this. This equation has an x in it and a k in it. That's all. And they want the x in terms of k. So basically at the end they want x equals, and they don't want a number here, they want some k's. Well, some numbers, I guess, and k's. So maybe like 5k or 8k minus 7. You know, something involving a k. Right, so we can just rearrange this. Let's get x on its own. Let's just rearrange everything, get x on its own. First thing, I'll add 1 to both sides, and then I'll multiply both sides by this here. Let's do that at the same time. So 1 comes over here, and I'm going to multiply both sides by this. So I get 4x plus 1 to the power of a half is equal to 2k. Hopefully you see where I got that. Added 1 to both sides and multiplied both sides by this. Basically got this over here. Well, don't think of it that way though, that's a bit off. Okay, I want x on its own. I need to get rid of the half here. And the power, square both sides basically, will destroy that. We get 4x plus 1 is equal to 4k squared. Take 1 from both sides. 4x is 4k squared minus 1. And divide both sides by 4. X is 4k squared minus 1 over 4. And that's the answer for part B. That's the x coordinate here in terms of k. And I just want to say this is quite useful in lots of things. Very often we know what let's think of a science experiment, or it doesn't have to be an experiment. Sorry, think of anything really. We often know what the equation looks like, but something changes. A k in this case, maybe the temperature of the room, maybe how many shares are outstanding in a company. Something regularly changes, but we know it obeys the rest of this function. So it's often very useful to do the maths like this, and then I can come along and say, well, k is 4, k is 7. I think in part C, k is 10.5. It's very useful to quickly be able to change k. Okay, I hope that answered part B. For part C, I have a little room here, but I'm going to rub it all out because I need a lot of room. Let's see, we'll keep this and we'll keep this here for part C. Okay, before I do part C, let me just repeat something I said a moment ago. The examiner wants this question to be hard. They didn't give any pictures. They gave a really awkward function. they're testing you. This is the last question in this paper. They are testing you. Being able to do maths basically without pictures is a little extra thing here. With that said, I'm going to respect that a little, because I'm going to draw a couple of pictures to help explain what I do. But on purpose, I'm not going to draw the correct pictures. Because a lot of you students won't be able to have drawn the correct picture, or in your next exam they might give another hard equation that you might not know what it looks like. So well, maybe I'll draw the correct picture towards the end, just in case you're curious. But for now, I'm just going to draw a generic function, a xy axis and a function that looks like this. It is not what this looks like, just something to help you along, okay? Now with that said, part C talks about, first it tells us k, so we're able to change k to 10.5, and then it asks us to find the normal to a curve at the point where the tangent to the curve makes a certain angle to the x-axis. Okay, so I'm trying to think, because I know what the picture should look like and I want to draw it wrong, just to respect what the examiner's meant here. So basically they're saying there's a tangent somewhere. I'll just draw a generic one here. There's a tangent here, and what we're looking for is the normal. So we're looking for the normal to that tangent. Okay, again, the picture does not look like this. I on purpose drew it as different as I could. But in your exam, it might help you to draw a generic picture. When you see tangent, tangent, okay, draw a tangent. And what's normal again? Oh yes, normal is the thing opposite the tangent. Oh, they want the equation of the normal. Oh, well that means I need to find the slope. And I need to find this point. Okay, so I just wanted to show you that without knowing anything about what this looks like, the drawing can still help you think through what you're going to do in this question. Okay, yeah, so where do we start? We need a slope of this normal and we need this point here. What have they told us? They have told us an angle. They told us the tangent makes an angle of the inverse tangent of 2 to the x-axis. That's this angle here. If you put that in a calculator, that'll tell you it's about 60 degrees, which obviously my drawing's bad then. Okay, so we do have an angle, and well, yeah, okay, well, I'll leave this drawing for now. It's probably given us everything we want. The next thing I want to say is we should be thinking slope. And what are we thinking in slope? M equals. Lots of you probably think y2 minus y1 over x2 minus x1. That's okay, but in this question, no, that's useless to us. They haven't given us points. It's not coordinate geometry. Next thing we should be thinking about slope is dy dx. The slope is equal to the y dx at x equals something. Let's say x equals a. Doesn't matter. Let's just think dy dx for the moment. And there's another thing we should think, which sort of helps us. We don't need it in this question, but it does sort of help. Makes it easier. We should be thinking it equals tan theta. So we know all this about slope, and that's one thing the examiner wanted you to notice. Right, so what have they told us? They've told us this angle here. So this angle they've told us is tangent of the inverse tan of 2. So straight away we can just cancel that, and we know the slope is equal to 2. So we know the slope of this guy here is equal to 2. And straight away we can find the slope of this one, the normal. The slope of this is minus a half. The inverse of 2. Turn it upside down and change the sign. Okay, what else can we tell? dy dx, we haven't used that yet. We know dy dx here. So let's write down dy dx. 2 times k, which in this case is 2 times 10.5, all over 4x plus 1, power of a half, minus 1. But we also know dy dx is equal to 2 at the point we're interested in. At the point we're interested in, we know it equals to 2. Look, there's no k, we can solve this. We can find x. We can find this point here. We can find the x point. And once we have the x, we can find the y. And that's how we do this question. Okay, I hope I explained how I got here. It's a hard question. It is a hard question to know how to start. I think if we made this question longer and explained other parts, maybe 80% of students would get it right. But they didn't. They didn't explain all the parts. They didn't hold your hand. They wanted to see, can you make these jumps on your own? And I don't know, but I'm guessing maybe only 60% got this question right. Okay, so the slope is dy dx. The slope is also 2. dy dx equals 2. That's basically what I've done. So let's try and solve this. Add 1 to both sides. We get 5. Let me do it slower here. This is 21 is equal to, 1 to both sides, we get 3, equal to 3. This guy's on the bottom. Let's multiply both sides by that. 3 times 4x plus 1, power of a half. Divide both sides by 3, we get 7. Let's see, take the square of both sides. We get 49 is equal to 4x plus 1. Take 1 from both sides. We get 4x is equal to 48. X is equal to 12. So we found this point here. We found the x part of this point. Next, we just need to find the y. A lot of students panic at this point. What do I do next? There's no y. Remember, the very first thing they told us was y equals. So we just write that again. Y equals. We know k is 10.5. Let me just box off a little room here. The square root of 4 12s, 48, plus 1, square root of 49, and minus 12, minus x, minus 12, plus 5. Let's see, this is 7. 7 times 10.5 would be 70, 73, 73.5. Minus 12 plus 5. You might notice the clock hand just skipped a bit because I made a mistake because I tried to do this in my head. It's simple maths, but I recommend always use a calculator for simple things like this. Let me try it in my head again while I'm looking at the answer. 73.5 minus 12 is 61.5. If you could see the edit, I said 71.5. Anyway, 61.5 plus 5 is 66.5. So y equals 66.5. So we're nearly finished. We have the point, we have the slope. I'm sure most of you can do this on your own, but let me just rub this out and I'll do it on the board. So remember, they asked for the equation of the normal, so we still have to give them that. Slope is minus a half, and the point is here. There's two ways. I'm often doing the other one, so let me do this one. Y minus y1, which is 66.5, is equal to minus a half, m multiplied by x minus x1, which is 12. Clean this up. Sometimes people leave it like this, but I like to clean it up. We would get y is equal to minus a half x, and what's that? That's plus 6 plus 66, which is plus 72.5. Final answer. The other way, which I usually use, is y is equal minus a half x plus something, plus c, and then I put these two numbers in to solve. So that is 66.5 is equal minus a half, 12 is minus 6, plus c. C is equal 72.5. So the answer is y is equal minus a half x plus 72.5. Same answer. Okay, I hope that answers. Oh, I promised I would draw this correctly. Let's just do it here. So you could do this at the start, but you don't have to in this case. To draw this function, it's a bit hard, but I guess I'll do it a few times. I hope you can see. The square root looks something like this. 4x plus 1, I guess it would move slightly over and would it squish down or up? I never remember. It would look roughly the same shape though, and just a little to the left. Minus x though is where it gets interesting. Square root but minus x, that means as we're going along this will dominate, it'll push everything down, it'll tilt it all. So we'll start here and we'll probably get some shape like that. And then finally plus 5 would just lift everyone up. We'd go up a little higher. So this question, they told us this. Some of you might be able to draw that, that's fine. And then they told us, what else did they tell us? They told us the slope of the tangent was 2. So the slope of the tangent being 2 should have told us it was somewhere over here. The drawing's not the best, but that's basically 1266.5, which does make sense. It's somewhere in that area. It's up high. It all works out. So I didn't draw this exactly because you don't have to, and you probably won't be able to in your exam draw whatever weird function they give you exactly. Okay, I hope that answers everything. If you do have any follow-up questions, please put them in the comments below. Until next time, have a great day.